right. Okay, so I'd like to make an array. Standard int. Standard lib. Alright, so two-dimensional array. Uint 8 pointer. So I know these are the size of 1, so I shouldn't need to do all that. So if I do my X dimension, well, let's do 10 by 10. Actually, let's do odd numbers. X is 7. Y is, oh, let's see. Yeah, let's do 13 wide by 7 tall. X times Y. Make. Okay, so make. Okay. So we'll go ahead and fill it with something. All right. So I think we'd like to go through for int. No, let's do this first. I'm gonna rename this X size. Ah. Darn it, I keep hitting escape. There we go. For int I equals 0, I is less, sorry, x equal to 0, x is less than x plus plus. Oh. Let's do a dot. Okay, so it's probably going to complain about that. So I guess we'll have to calculate our offset just manually. Offset is equal to so x is this direction, so we're adding x, we're taking y times x size, and then we're taking that whole thing and we're adding x. So I think it makes sense to do it this way. So y is each, so x is this direction, y is this direction. We start off row 0, do that. Okay. So this is how you can multi-dimensionally figure it out, which is what a compiler would do if we did a malloc event pointers and then made each of those point to something. Instead, we're just using a byte buffer, which is what your compiler is going to do anyway. So, all right. And then we should define a function. So here we're defining it. So if I define it here, it's in my main. I think we can statically define it. Right. Static. Yeah, I think I have to say static in front of it. Okay. That way we can export a function called void print. We'll just do our printing for us. We can do it here for now. Which means we probably want these to be, I don't know, some people might say you should pound define them, but it should be fine. Okay, so our loop becomes this. I'll just copy all this. So instead of printing it, we can print a character and then call puts, print a line. There we go. Oh, forgot standard IO. There we go. Oh, let's see. Oh, I need to put this. Declare it before. Too few arguments inputs. Okay. Puts. What's a string? There we go. Hey, now I got it printed. Alright, so this is the simple way we could also add colors and turn that into a string. But that might be, well, that'll be future. Alright, so if we want colors, then we'd have to look up the ANSI escape codes to get them to print off. Which we'll do. That'll be fun. So that's how that's how you get all of your colors there. Which I use them for my terminals, of course. But we can embed those in either the same array or a different array if we really want. So, yeah, we'll work on that. Hey, look, they have a hexadecimal. All right, 1B. That'll let us do our escape sequence. And then I think mostly we want to set the foreground color. See, this is okay. All right, so yeah, 1B. I think that was what it said. All of that to print an A in red. That's good. Okay, so we have our stuff to print our array. And then I think what we'd like to do is we need to pass in. So I think I can just say that this is extern. So I can initialize my array. Here, let's move the print down here. We'll call ASM main, which is here. So we're going to tell it that I mean, we can either pass it in as a function argument or we can just say this is extern. We'll start with extern. And then we could pick an offset, move R8, let's say 5, load R9, value of my array, add, okay, I guess I didn't need, add R9, R8, move into the location of R9, the character, and just pick any character we want. And I gotta say byte. Yeah. Oh, maybe it's global. My bad. My array not defined. export C array. I thought I had done this already. Let's see. Core v1. Let's look at that. Maybe I did pass it in. Yeah, it's probably easier to pass it in. Okay. So instead of saying void, we can say uint 8 underscore t pointer array. And then when we call ASM main, we can give it my array. And then in our assembly code, instead of saying this is some sort of external, we can say my array is a quad word, say it's 0, load that in, move R9 RDI. So it should be in that register, so I should be able to put the value there. But I need to do it this way. RDI already has the value. I think that's right. Load the address and then save into that. And here we're going and getting the address of R9. Oh, I think we need, well, okay. Yeah, and we're dereferencing it there. Oh, that's not what I wanted. Well, I initialized it, right? Oh, did I print? Yeah, yep. Well, let's debug it. Why? Oh, I must be writing into a different spot. So my array is my local pointer. Load that address into R9. RDI should be that pointer. So let's debug it. Break main run. All right, so let's go through. So here we're calling malloc rix has this address here. Okay. So now we want to break ASM main, continue. Okay, so RDI has that address. Okay. Okay, so this is RIP based, so that means it's based on the instruction pointer, so this should be pointing to the right location. Again, that's 92A0. Next instruction. We're saving RDI. Oh. Why is it moving zeros? Oh, oh dear. That was bad. Okay. I'm an idiot. Okay. Why? Oh, I messed up my template. Okay. Well, that was surprised I didn't get a seg fault on that cue. Okay, so I definitely shouldn't zero them out. Oh, I gotta fix that in my template. Okay. Well, let's debug it again. Next instruction. malloc. Okay, RAX. Yeah, amazing. Same memory address. Pretty sure. Yep. Okay. Break ASM main. Continue. Okay. So now I'm not zeroing them out. Step instruction. Okay, so RDI has that address. So move RDI into this location. So let's examine $R9. Let's do. Okay, so it should be a keyword. I set it to 0, so this next instruction should put that address in there. Now if we examine it again, 92820. The right address is in there. Move into, so our offset is 5, step. So R9 should have our address. R9 does. Oh. So I need to get the value at the location. Again, I missed one level of indirection. Okay. Move into R9. Value at R9. Hey, there we go. Alright, so we're able to put a character in a spot. And that would probably be a handy thing to do. So we want to now we could either do so we'd have to figure out the dimensions. audio is only coming out one side. Oh, that's not good. Let's try that. Is that better? You guys will have to let me know. I turned on something because it's a little hot in here, so I got a fan going. All right. Hopefully that's better. I'll check chat. All right, so we could write this function one of two ways. We could give it 3 arguments. So RSI, RDI, RDX to say our X and our Y that we want to do. We know where our buffer is, and our value. I almost feel like setting up the function is as much work as this is. Like we could do that there. Mic is quiet. Okay. Why is it out of one side? I don't know why it would be mono. Oh, let's look. Oh, it does look mono. I've never had anybody complain about it. So now that should be better. My bad, guys. So Abdullah, is that better? All right. Okay, so we have our array here. And so I think, so one of the things that I used to do with my students is we would make a game called Super Assembros where you could move the character around. So I think being able to visually represent what we're doing is helpful. So, being able to move these in is probably a good thing. I don't need that anymore. So now we have dereferenced our pointer for my array. We then take the value there. So we get the value of so the first pointer is to point into static memory. Inside of our program, we have a reference to it. We keep it there. That way we can not worry about it getting destroyed. But that means that we have to dereference it twice. So we have to get the value at there, which is our pointer, to the location. And then we have to get the data at that location. And then now we have the actual pointer to memory, and so we can write that. Well, OS is maybe a loose term. So what we'll be doing is, so what I'd like is to be able to have threads that are running. So start 2 processes, and they sort of both run in the same memory space, and they can attack each other in some method. So it's modeled after, I think, a couple things. So I've shown this on stream before, where you can have these assembly programs that are battling each other, and so we can, instead of making up a fake language, right? So this has its own assembly, an abstract assembly language. Like I'd like to just write it in assembly, and then have them use any instruction they want to. Now they'd be limited, like we can basically should be able to disable system calls so that they can't do a variety of things. That would be in theory. But also, like, what I'd like to do is, if you look at the game of life, right, one of the things with this is that, like, you have to sort of interact with the squares around you. Like, and these are autonomous, but I don't think we want to be autonomous. I think we want to make it so that, you know, if a program is, say, stored in block B, right, in order for you to write to that, you would have to have free blocks around it. And so, you know, making you find the other code, right, we can visually represent where the different programs are and sort of what they're executing within that. And we already did one example where we had one. What did I call that one? Well, I think it was this core one. I have that open. So our main was going to be sort of the main loop, right? To be able to allow these things to interact. And, you know, you got some different exit conditions that we can have. So, you know, if, you know, you can think of a lot of different ways that it could crash. Like, you could have a secret that you got to figure out where it is, or you could force the other one to exit. So if it segfaults or crashes, right, then it's done, and you win if the other one crashes. So that would be interesting. You could make it so that you have an exit code and you got to make them exit with that exit code, right? So that would be sort of more difficult. But I think the goal would be to be able to launch these standalone things in Linux, but not let them do any system calls, but let them sort of run in assembly, right? If we don't tell them where anything is, hopefully, well, clearly things can go wrong when you think about it from a security perspective, but that's not the point. The point is to make it fun. So what I'd like is for people to be able to run these and have them battle each other and see who wins, or you have people do different strategies. You know, we run it in a virtual machine. If they break, then they break. But I think that's more fun than having a made-up language like Court Wars had. I think it's just allowing, okay, here's your binary code and go, and it starts executing the first instruction you got. And, you know, the thought on this is that if we define a data structure where these two can easily interact, right? So if you want to write data, you know, maybe you go through that, and it can filter it, right, and say, no, you haven't written, like, if we think of this as having some additional blocks around it, like, you can't write to location B because you haven't unlocked the areas around it. You know, that type of thing. So then we'd have to have checks and bitmaps and all kinds of fun things. So anyway, that's to answer your question, Make an 8. That's kind of the goal, is to define a system. So I'd like to sort of do all the fundamentals, right? If you would look at my YouTube channel, we'll be doing assembly videos. Last time I did like rotation and shifting, right? So those things will be important. But I think what we'll do is we can go through and sort of just do some basics in the assembly, and that way we can understand how all of this is going to work. So yeah, that's the goal. for doing this, right? So teach some fundamentals and then work on this fun project of having these executing threads. I think I drew a diagram before, but having the executing threads battle each other. I should bring that up. I should not sure if let me see if I have it open. Let's see. I think I do have it. Okay. Yeah, so there's a lot of different ways that we could do this, right? We could make him go through an interface. That would be one way. Or, alternatively, we could have, sort of program 1, program 2, and if we think of our memory as one, we can think of it in 2 dimensions or 1. You know, that really depends. But you're allowed to read and write anywhere in memory, and so I think that becomes the interesting part. So I think that's the goal. But we got to start with the basics. So here it was at least learning, like, how can we write to that memory? So I think the scanning it, right, would be something else we'd want to do. So this is the move one, but we could envision doing scan. Scan for character. And then we got to define, okay, so we have our prologue, which I did see some, if you look in the macros for NASM. I think they had one for prologue. Oh, yeah, it was prologue. I don't remember if I put those in. No, I don't think I put them in my main one. But it is interesting that instead of having to remember to do this every time. Let's see, epilogue. So we could do that. So we define that as a macro, except we're 64-bit, so this is RBP. RSP. And then on our function we can say prologue. I think that's how we say it. Of course. And then I think that's in, see, that's in bytes. So here I just want to do 0. The end, right, we should do, so our epilogue looks like this. macro. Takes 0 arguments. Does that. And macro. So now our functions look like, hey, they look like C functions, which I think is interesting. So I think that should assemble. Make. Yep. All right. So if we'd like to scan for a character, so let's suppose we want to do that. We're gonna have to go grab our. All right. So this will grab our address. Get the address. So we grab array, move it into R9, move the value of R9 back into R9, so we dereference that pointer. So now this has the address. Okay. And then, so we want to keep track of an offset. So I was using R8, so move R8, the address 0. Now it depends on, so I guess we can use a different one. So move R10, the value it's in R8. Let's put R8 at the top. So this is our init. Our counter. So we move our counter into there, we add in R10 the address of R9, so now we have this new address, and then our value. So we want to get a byte. I think we can use R10. Maybe. Move R10, the value at R10. So R10 has the address that we want, but actually we're wanting a byte, so let's use RAX. So we can use AL, because we only care about a byte. Okay, and then let's use CL. Move RCX 0. So this will be the character to compare to. Compare to. And then we can do compare. Oh, we gotta move. So I think the character we're looking for, we'll assume, is in our RDI. RCX RDI. Compare AL CL. Okay. So if it's 0, we got several things to compare. Jump 0 dot found. Found. Move RAX R8. So that's our offset. So we found it at offset. Blah blah blah. If we didn't find it, move RAX. Let's say -1, right? So that would mean that we couldn't find it. Alright, so if it's not 0, we need to add R8, 1, and then jump to the top. So R9 should still have our address, so we don't have to redo that calculation. But we want to load the offset, add it to R9, so I think this is our top. So, okay. And then here, jump to .done. Which exits our function. And then we also have to, so RDI is the character to look for. RSI would be our max. So how far are we gonna look? So here we can do compare R8 to RSI, right? I said RSI. RSI is our max. And if they're the same, jump 0 dot not found. So if they are the same, then we want to say, oh, we've hit our max. So in our main program, we can do something like my array bracket, let's say 6 equals C. I want it to be a character. I help if I can spell right. All right. Label alone. Okay. Yeah, I think that's probably okay. All right. So we need to call our scan for character. So I did make it. It looks like a standard C function. So I should actually be able to call it in main. So here I can say int scan for character. That takes a character to search for, char C, and int long int 64t size. Now in here, I'm going to have to tell it, so it's a lot easier to call it in C than calling in assembly. So to test it, let's call it in C. So we're going to say extern scan for character. No, global. That's how we export scan for character. So I took standard C arguments, so I should be able to do scan for character. I'm going to give it the letter C and a max size of 20. The location is %d res. Question is, will it work? Maybe. Yeah, Sigfold. Sweet. Alright. So, what did we break? Definitely broke something. Oh, I think we didn't do a ret. Oh, we did do a ret. But we didn't do move. Oh, I didn't copy enough. Push move. So I should do move RBP RS. RSP, RBP. Seg fault, yeah. That happens a lot. Alright, so I guess the question is, where did we seg fault at? So, run. It's in scan for character top. So, I'm guessing it's here. So let's just break there. Break, scan for char, run. All right. So RDX, okay. So it's got a C in it. It prints it off nicely for us. That's good. Okay, so next instruction. Load effective address, R9. Move R9 keyword, so that's right. Right size there. So R9 should have, no, it has 0. Did I do one too many dereferences? Let's look. Examine. 0x. So I think it's showing me what it points to. Ah, we broke it. It never worked. So R8 has 0. R10 should have the value of R8. No, this is where it broke. So my array into R9. My array into, oh, I didn't call ASM main first, so I didn't get the address. Dope. Okay. So we need to actually call this first. Before, or I'll just move this down. I can drag things. Let's try it again. Q. Ha ha! We found it. So because my ASM main sets up that pointer, the nice thing I put a 0 in there. So it gave us 6, 0, 1, 2, 3, 4, 5, 6, which is what I set it to originally. All right, so now this allows us to at least look for that character. So I think this is probably about the end of the stream, but so next time I think we'll extend this, right? So if we want to search in memory for a particular thing, we can write that in our assembly code. So here we've got at least a method of searching where we can search for it. Now, additionally, we could try and do smarter things, right? This is scanning 1 byte at a time, looking for that. You know, we could scan a whole keyword at a time, and see if it's in any of those, but then we're going to have to use our SMD, single instruction, multiple data. Oop. SMD, XMM, string. There's fun ones. Test if, see, here we go. Test if any byte in XMM is 0. Well, that means you can actually scan for other things. Yeah. So these packed instructions will be fun. So we'll do that in a future one, where we do sort of more efficient searches. But at least here we're able to load the array in. We're able to do our scan for a particular character, and if we follow the C standards, then we can at least test our stuff in C, where it's a little bit easier to sort of pass in arguments. But we'll do them all in assembly. So, plus now we got a prologue and an epilogue. Hey, we can use that. We'll throw in some locals probably too. But all right, well, thanks for watching and commenting, and we'll talk to you guys next time. Thanks, guys. Bye.